We've got some servers to look at today. They're pretty old. It's a ProLiant DL380 G4 and this one ML350 G3. They're fairly close in age. This is something it looks like you can have as a desktop style computer or put it on its side and mount it in a rack. And they both have these Ultra 320 SCSI drives on the front. 36 gig, 72 gig, 146 gigabytes, 10,000 RPM, but there's no drives in these. They've all been removed, probably for security purposes. So just all empty carriers. And this one here, you can see that's a slot blocker thing so that the airflow still gets distributed properly when you don't have all the drive bays populated. So these were being scrapped, so I grabbed them so we can have a look in them. These things can recover the aluminium out of them. Let's have a look around the back. On the back of these servers there's external SCSI, so you can add additional drive enclosures or tape drives, standard sort of things that you'd see on a computer, but it has, that's the management interface in addition to the regular Ethernet and some kind of UID button. And on the other one it's pretty much the same thing except less Ethernet, and it doesn't seem to have that management thing. I guess that was in a separate option. There's power supplies, the option to have redundant power supplies, so if you want you can take that out and put another power supply in, and these will be hot swappable. So that's, see, this is back before they were all just 12 volt outputs. It's more like a regular computer's power supply. 500 watt PFC, and this one, which has both fitted, this has got 575 watt power supply, but this one it's just a 12 volt rail and a standby. It has got a minus 12 volt rail, so it's moving towards that system where everything is run off 12 volts. So 2 power supplies there. We'll take a look inside those later. Let's get the cover off this and see what's going on inside it. This flap, so you can access for the PCI slots, fans, 2 CPUs, a little bit of RAM, some voltage regulators for the CPUs. That's where the power comes onto the main board. Then you've got a whole row of fans. Not sure what the rating of these are because they're covered on both sides, so we'll have to take one of those apart to see. And then there's a back plane that the drives connect into, and you can see some ribbon cables which go from the back plane and will go onto the main board. Should be able to get all the fans out as one unit. The fans plug into these headers down there. It's quite neat. And then there's SCSI and also IDE for the CD-ROM drive by the look of it. It seems to just tap onto there and back off again. It's a bit weird, isn't it? It seems, oh, they call that FLP USB. Is that bringing, probably, the USB from the front panel comes through that back plane. Okay, so that's called IDE SW, maybe that's got the power switch on it as well as the IDE, whereas that's one there is SCSI, and that one's SCSI as well. So 2 channels of SCSI going onto the back plane. There's also some chips on there. Okay, and then there's PCI slots, and PCI X, so full 64-bit, and then there's an interesting way of undoing it. You lift this up and then it allows you to use the screws without needing any tools, and then that should lift up, and then the whole PCI bus is pulled out so you can easily get your cards in and out of it. So there's that extra SCSI card. There's even thumb screws on the retaining thing for the cards. That's nice. This Torx thing, which looks like an Allen key, stores in here, fits the screw here, so it can be undone. Is that a standard thing under these clips? No. Okay. Interesting. So there's clips to make it yeah, toolless. Some kind of SCSI card, possibly 2 channels, PCI X 133 MHz, LSI logic, pretty good. And so that will have some sort of PCI to PCI bridge on there to expand that out to 3 ports. So underneath that, you can see a bit more of the motherboard. Rage 128 is it? Or the Rage XL for VGA graphics. And then got CPUs. That thing lifts up, and then you can release the CPU, and the whole thing comes out attached to the heatsink, which is quite interesting. So the thermal interface seems to be permanent. Hopefully it's good then. Quite an interesting concept there. And we'll have to come back a little bit later and carry this on. It's the 5th day of not having any power, which is why we're still recording videos in this way. I did manage to get some more petrol for the generator, so I was able to get some things charged up. This is the type of fans that are used in this server. 12 volt 1.2 amp Delta brand. So that just unclips this top part here. See, it's got little dimples that go into the holes in the corners of the fan, and then that's holding this metal bracket thing on. You can see it's got a status LED as part of the fan there, so that will tell you if it's okay or going bad. So that's the fans. The back plane should be fairly removable, probably by these. Undo all this stuff. Some sort of SCSI cable to IDE adapter there. Now there's power going onto it there. And then there's these things going onto the front panel. So that's a 6-pin micro ML, maybe? Microfit 3, is that what it's called? And then there's something else going to this end. So what are those? Oh, a whole bunch of LEDs and the power and reset switch. And on that side it's a USB connector. Okay, so this should come out now. Okay, so that's SCSI backplane, 6 connectors. And you can see there's LEDs there for each drive. And the carriers, trays, whatever they're called, they have 3 light pipes which go down the inside edge and then over to the front where there are 3 LEDs. Let's have a closer look at that. Okay, once you undo some screws, then the whole thing comes apart. There's some aluminium parts. And then the light pipe assembly is just 3, I don't know what it is, polycarbonate type springy bits of stuff that go through, and then it will light up the little symbols on the front depending on what's going on with the drive. So the back plane, it's got the connectors. On the back side there is some microchip PIC 18F4320 microcontrollers. Maybe that's to do with flashing all the LEDs. Dunno. Then there's this thing here. I wonder, it is a terminator. Look, it says on a terminator board. I'm thinking, is that a terminator? And yeah, it is a terminator. It's the end of the SCSI. It needs to be terminated. So that's the terminator. guess it's an active one using some chips. So I guess that means that you can have a cable coming off that going to other stuff instead of terminating it there. Jumper cable in simplex, terminator board in duplex. Oh, does that mean you can have this as one bus or two buses? So you either link it back on itself or you terminate it. Okay, so that's probably not a normal terminator then, is it? It will be a dual one because it terminates both buses, or you can have them combine into just one bus, because we saw there were two interfaces going across to it, so it must be 3 drives each to get better performance. Alright, well that's interesting. Okay, I guess we'll get this board out and we'll take a closer look at it, and then we'll take a look inside this one here, which is pretty similar, I think. Well, the CPU mounting is similar, but the drive bay thing is different, so we'll come back to that after we've finished off investigating the board on this one. Okay, it turns out it's really easy to get the board out of this. All you have to do is undo that, and then that power supply thing just comes out. So that's on some little keyhole post thingies. Go into those, and then the whole main board slides forward. Presumably it can just lift out. Guess so. Can. Oh, there you go, that's out. Easy hot swap motherboard. Well, it's probably not hot swap, but it's pretty easy to swap. Get those out of the way to make it a bit lighter. So big chunky heat sinks. Now let's carry on, although it got dark. On the front of the server, I notice the CD drive. There is a thing here you can push, and it releases the drive by pushing a lever just here. So it unplugs at the back there, like that. That's just a standard sort of drive with an extra bit on the back, like what you would find in laptops. And then there's this other thing, which I'm not sure what that is, but that I guess would be another drive of some sort. Don't know what would go in there, because there aren't any connections. Then there was a USB port, Foxconn, with that micro ML thing, or microfit 3, I think that's what it was. And then the LEDs and the switches, which were on this other side. Now we got the main board, the CPU sockets with that long range lever to release them, and then there's the CPU power supply modules. Got some interesting inductors on them. Some kind of power supply controller chip. I guess we should pull that off and have a look what's under there. Be some kind of surface mount fits, I guess. Yeah, squeezed in there. Okay, here's 2 of those, one for each CPU. There's one of those, whatever that is. Oh, that's soldered on, okay. Some other interesting, nice, flat, bar wound inductors. It's where the PCIe riser come in. There's that. Don't know what that is. Maybe that's a management thing. Don't know. An IC of some sort. Perhaps that's a SCSI thing, maybe, since there's the onboard SCSI there. And that's got another kind of thing. Maybe that's some kind of chipset thing with a very brittle heatsink mount. Broadcom, that will be for the Ethernet. It's probably a dual port chip. There's a reset button. The other voltage regulator. And then RAM. This looks like there's two different types of RAM in this. What are these? 512 megabytes, two of those, and then a different one, also 512 megabyte. Wow, so this thing only had 2 gig of RAM. ECC RAM though. Looks like I cut my finger or something. Okay, anyway. So that's the main board. Is there anything good happening underneath? You can see the bypassing capacitors around where the CPUs go. It's under the RAM. There's a couple of little ICs and things here and there. Various logic. And then under other chips, bypass capacitors. Pretty good. Now the power for the board come in through that, which looks pretty similar to the normal ATX connector. It's a bit surprising because you think there'd be more, it would need more than just that, because, yeah, anyway. So that came from this thing. Oh yeah, it did have more, it had this other connector as well, so I think the controls and sensing were done through that. So this is all high current power supplies. They're not even using every pin, are they? I don't know, it's just all grounds on that side, almost all grounds, and then various voltages. And then if we look in here, you can see that's where the power supplies plug into it. Hot swap power supplies. And now under that cover, you can see there are some regulator modules. So it says 12 volt DC input. Doesn't say what the output is, but I assume that will be making the 5 volts and the 3.3 volts, since we didn't have that on coming out of the power supply. So I think that's what we can see here. So there's 5 volt auxiliary, 3 volt auxiliary, and there's 5 volt SCSI, 5 volt sys IO, 3.3 volt, 30 amps max. Is that all coming out of those little thingies? Another one there for something else. Because there's the power supplies that push onto that. Yeah, they're just 12.15 standby and minus 12 volts. Yeah, so these things here will be making the 3.3 and the 5 volt rails. And there's not much going on the bottom there, just various bypass caps and other little bits and pieces. Okay, well that's the full teardown of the 2U DL380 server. Let's move on to the ML350 server. This stuff will go to recycling. Now I think this is very similar. You can see in there the same type of heatsink CPU arrangement and possibly a very similar power supply. Well, no, it's not similar, is it? Because we saw that this one has the power supply itself outputs the 3.3 5 volts. It's not a separate regulator. Oh, there's cables that are tied in here. Anyway, so first thing, there's an air baffle here. So quite a large fan on the back is used as the CPU fans with this baffle. Oh, you gotta take this piece off first. Then that can come out. Now in here we see the same type. These things lift up, and then there's a lever. But interesting, these are aluminium heat sinks, whereas on the other one they're completely copper heat sinks. Quite a bit heavier. Well, I guess this is the one generation older, so it's, yeah, that's what they did back then. We'll just get these out of the way. Interesting that that RAM slot is spaced out differently. what have we got? 1 gig. Oh, there's more RAM in this one. Presumably, if these are also 1 gig. 1 gig. Okay, 4 gig RAM in this older server. Okay. And then we've got a similar sort of processor power regulator thing. So 12 volts input, and then will be whatever the CPU is asking for coming out, like some low 0.9 volts or whatever. This time you can see what devices are being heat-sinking through the board. Lots of wires through there. Pretty good. Now this one, it's got 2 connectors for the power. It's a little bit different. Fan out of the way. This must be a 120mm fan. You can see on the connector there's a little loop there so that the motherboard can tell that you've connected a fan or not. Okay, so 36 watts, 12 volt 3 amp fan. Pretty grunty fan. I wonder if this board comes out as easily as the one from the other server. Not sure. Maybe similar. You can see there's keyhole type latching things at that end, and then there are some screws at that end, so maybe undoing 4 screws and it will come out. If we look in the front section, there's a drive bay thing, and then there's some more sort of normal 5 1/4 inch type bays there, which there's a floppy drive and then a CD-ROM drive, and then there's this bottom bit which has got a backplane and then SCSI coming onto it somewhere. Oh, up here, it's already been disconnected. Oh, I think I pulled a cable out already. Yeah, because there was a SCSI card in there, that's right, and it went onto the backplane. There's several other SCSI cables in there. There's another fan here. I guess that assists with the PCI and with the drives. Yeah, that will be a difficult fan to replace if you need to replace it. It's hard to reach down there where it's plugged in. They all look like PWM controlled fans. That one's not very grunty. There's another bunch of wires there. Presumably that goes to this front panel bit that has buttons and a whole row of LEDs on it to tell you what's going on. Okay. They used blue instead of yellow. Presumably that's the 12 volt one, unless I've maybe completely swapped it around. So in this case there's no active stuff on this power receiving distribution board because the power supply outputs everything. You can see they put a pin out there. Must be an enable somewhere. Lots of 3.3s. See, it says there 3.3 volt remote sense, 5 volts or 12 volts as well. More, oh, that's the other one. Removing that clear cover from the other side, you can now see there's some writing around these connectors here, those wires. This is present 2. You'll see a present 1 there, so it can tell if you have both power supplies connected, and if you remove one, or presumably if one dies, it would tell you. Stop saying that it's okay. There's clips down there holding these. An IDE cable, another SCSI cable that's wrapped around that top piece there that has an active terminator on the end of it. And then there's the floppy drive cable, just for one drive. There's the twist. Now I think we can get the board out. If we unplug that front bit, then undo 4 screws. Probably will slide back and come out. I'll get rid of these screws. Okay, let's see if this will just slide back. Looks like it. You have to pull it up from this side. Oh, and the heatsink thing's actually down because they need to clear that. Okay, it's a bit more like workstation style than the rack mount server board. This one looks more something like an extended ATX form factor, but with a bit different screw holes. But it has got what looks like a standard ATX I/O shield on the old school style with PS2s on it. And again, there's not much going on the bottom. Some chips, probably less going on the bottom than the other one. SCSI there. Some other thing, a Compaq chip, something with a heatsink plate on it there. And another Rage chip, Rage XL for the graphics. Broadcom, be the Ethernet. It's just a single port of Ethernet on this one. Get 2 USB ports. Alright, finally we'll take a look at the front here. It looks like the drive cage can be removed by undoing 4 screws. Those were for holding the cover on. Okay, see what this thing does now. What it does is, you see those screws that are into the drives are in slots. So this thing here is a key hole thing over the back screw. So when that's pushed up, then the drives can be slid out. That's convenient. So optical drive, pretty generic as you'd expect in a server. Floppy drive, Citizen brand, and then there's a blank, and another one with a SCSI cable tied around it, and that would allow you to mount 3.5-inch drives into those bays if you wanted to do that. Now this thing, yes, look at that, it just slides out. Will it go in here? No. No, it doesn't go in there. But I did see somewhere you could get another drive bay thing to go in there. I guess that's what that SCSI cable was going up there for, so that you could use it. Okay, let's look at the back plane that this thing has. It's got some sort of cover over it. There's with a SCSI and its own power connector. Okay, I wonder why that's all wrapped up like that. Just to stop dust. I'll get this packet off. Alright, this is the back plane. You see it's got the LEDs there that shine down the light pipes in the drive carriers. ABT573, some standard logic bus driver thing. Then there's on the back side, got some nice tantalum capacitors. Good smoke will come out of those if you're not careful. Some resistor. A G logic chip. 10 MHz oscillator by it. And what looks like a 3.3 volt regulator. Some interesting resistors there. And some other chips. So there's a backplane for SCSI. Alright. That's the whatever part number this one was, ML350 sort of rack mount sort of desktop server. Now we've got one more to look at. I'll just go and grab that. Okay, the final thing we've got here to look at is a super micro server 3U. It has triple redundancy power supplies when you have them all fitted. Swappable again, and that's also a standard like computer type one that has all the different outputs. So yeah, up to 3 of those installed, and it has that type of connector, a little bit different. And you can see that's also just a standard like EATX style motherboard. On the front, a lot of drive bays, and a serial port, USB port, a couple of really tiny buttons, and then a DVD drive. So these drive carriers, yeah, they're a bit more flimsy than what we saw on the Compaq servers. There's a lot of them. This is for big storage. 4 bays high, 4 along, so that's 16 discs you can have in there. Alright, let's get the top off and see what's in here. Okay, it's already been gutted a little bit. You see the CD-ROM is not hooked up anymore. Oh, and that thing is missing a bracket or something. There's a boot drive which should mount somehow in that. There must be some bracket thing or into that. And that's just SATA. And then there's a backplane in here. Oh, there's multiple backplanes. I think it's one per row. Yeah, because each one is 4 drives, and then it's got those mini SAS things, whatever you call those, SFF something or other connectors. So there's 4 of those down there, and then those will come over here to where you'd put some sort of RAID card in, and they plug into that. And then on the motherboard itself there is a bunch of SATA connectors. So I think just the onboard. I think there's onboard RAID and maybe some generic ones. Oh, look, there's also some Compaq flash header connector and IDEs. It looks like there was options for SCSI if you have that fitted. And there's some pretty regular CPU heatsinks, fair bit of RAM, and then on the back there's these fans. Help get some more airflow going through it. Presumably you can change those easily. Sunon 10-watt fans. Pretty sure this server is a Core 2 era Xeon, whatever that makes it. There's these fans here, which I think unclip. Yeah, these are very strange ones. You see, they've only got 3 blades. Delta brand fans. I think there was more. Oh no, there's a different set of fans that goes there, and it's been taped off to not mess up the airflow. Pretty sure I did that when I was trying to use this thing and trying to reduce the noise that it makes, because those were screaming fans that you'd have when there's long length PCIe or PCIX cards in there. So the output of this power supply is just what you'd find on your normal ATX stuff, where you've got the EPS 12 volts connector, and then the 24 pin, and then the ATX 12V connector. So standard things that you'd see on fairly current motherboards, because this is just a regular eATX motherboard. So that nice redundant power supply thing you could use to power your desktop system, if you could deal with the amount of noise it makes from its fans. That's going to be the thing that makes it difficult to deal with. There's some extra wires there. There's a button on the back which you push to silence the alarms, because alarms will go off if all 3 power supplies, unless you have all 3 power supplies plugged in and working. There are alarms. Alright, I gotta get some of the stuff unplugged so we can take a look at it. Okay, on the back plane, I think that's ready to remove now. I think. Maybe not. Oh, I need to do all the trays to be taken out first. Okay. And what a job it would be having to load all of these in racks and racks of servers. Okay, let's see, does it come out now? No. Yes. Pull it hard enough. Forget to unplug the last power connector. See, it's got 4. There are 4 back planes. Each one takes 4 SAS style drives. It probably would fit IDE drives as well, I'm not sure. Or, I mean, probably would fit SATA drives, I guess, or SAS drives. And each one of those 4 things has got 2 of these power connectors, and this bottom one is incredibly hard to get out, so hold on a second. There's one of the back planes with these SAS connectors. That has some little chip on it. Lattice, so I guess it's some sort of little CPLD involved with maybe flashing the LEDs, something like that. So now we got all those power connectors removed. Oh yeah, there was this extra piggyback things were in here, which for, I think, a power on LED on the front, and for going to the SATA boot drive. And there's also in here a fan distribution, power distribution board, where that then wires onto all these little connectors along the bottom where those fans plugged into. It's a pretty interesting system there. Okay, I'll have to untangle all this to get out the power supply. Here are the details for that combined 3 redundancy power supply thing. So it's up to 800 watts, and then in the back of that was this board, which is where the 3 power supplies connect onto, and it's got all the wires soldered onto it, quite a lot of wires, and there's also some kind of control board thing in there. I guess it's for sensing what's going on, and probably for controlling the balancing between the 3. I'm pretty sure they have a balance signal. And interesting, some of those fans are connected onto the motherboard directly. Just those 2, but then there's that other big one and 3 small ones all came off that fan distribution power board, so those will just be going full noise the whole time. Oh no, look at that. No, all 3 of those big ones were on. It's a little bit weird, because where is the 4th one then? Maybe there's only 3 coming off that distribution board. Anyway, that's all fan power connected thingies. So there's the main board. It's just a standard E80X board, and it's got this special slot here for an IPMI card, which is its own little processor thing that allows you to do a remote KVM, remote controlling of this system over the internet, or over your network at least. IPMI, IP Management Interface. So when you plug in the power, the standby power will power this up, and it will start running and providing some services over the management network, allow you to remotely manage your system, including mounting images and booting off of it remotely. So you can do full reinstallations of the system remotely over the IPMI. So what RAMs do we have? 4 gigs. 4 gig modules. They look quite fancy, don't they? With heat spreaders on them. So how many of those are there? 8, I guess. 32 gigs of RAM. Not too shabby, is it? Except it's all old, slow CPUs that are very power hungry, so it's not of much value these days. What a shame. Well, I guess that's why it was being thrown out. Oh well. We'll finish off by taking a look inside the power supplies from these 3 systems. Okay, that's the type of CPU package this Supermicro server has. I had to take off the heat sinks to get it out of the case, because the studs go right through and secure the heatsink from the bottom of the case. There's a little plate thing which is being pushed through the board, or clipped into the board. It's still the same as that modern type, isn't it? There's a little bit of crust in there. It's not very good, is it? Oh, it's some heatsink paste has gone in there. It's a bit dodgy. Oh well. This is just not worth using anymore. It's too slow and too power hungry, so it doesn't really matter, does it? And here, that's what's on the bottom of the CPU. Some little resistor network things and some capacitors. Or is it capacitor network? I think those side, yeah, that's what it is. Side terminated capacitors, lower inductance. A lot of nice looking solids type capacitors, and lots of inductors and lots of FETs. Probably some of those being used as diodes. Yeah, no separate voltage regulator cards. Which reminds me, we needed to take the heatsink off of the other one to see what was under it from the first server. This thing, let's see if we can get that heatsink off easily. Not easily. Okay, that's quite interesting. That was very well stuck down. Double-sided tape stuff and some sort of glue. But look what's under it. It's some kind of, presumably, like die-on board FET, with then has a cap soldered on over it, maybe? Or is it a leadless package? It's probably not a die on the board, it's some sort of leadless package with a metal lid. Kind of BGA or QFN style maybe, not sure. And then that gets squished with this glue under the heat sinks. Look at that, the windings in parallel on the inductor. So it's got those on both sides, and then large solid areas with through-hole wires connecting the copper layers together, dissipate the heat out of it. Interesting thing. Is this format of video good? Perhaps we'll reuse it for other big items, but it seems more convenient for big things that don't fit on the bench. Anyway, finally we'll take a look at the power supplies. The recording that's going to have to wait until the next day. We've got 3 power supplies here to take a look inside. First, let's just have a look at the CPUs that come out of these servers. This is solid copper heatsink. It's got an anodized aluminium thing around it. I guess that's to make it easier to grab hold of. Whereas in the other one it was copper with the similar looking thing around it. CPU seems to be permanently attached. I guess it's just some double-sided thermal adhesive, and it could be ripped off if you tried hard enough. They've unscrewed that piece on these two, and it's just individual fins not attached at the top. So I guess that thing holds them together so that they don't get bent out of shape. Getting a screwdriver under there, it was possible to lift them off. It's just normal looking paste there that has glued them down. So this yellow frame thing holds onto the chip, and then that clips into the heatsink, so it will just stay as one assembly and not fall apart, but is removable and serviceable if necessary for redoing the paste. So that's quite a neat system, and nice that you can release the processor from the socket before pulling on the heatsink, so that you don't do what often happens on consumer stuff where you end up ripping the CPU out of the socket when trying to remove the heatsink. Anyway, we're going to look at some power supplies. So I'll take it apart and then we'll take the cover off and then we'll explore them. We'll start with the Super Micro power supply. This one, it's got the lid is aluminium for heat dissipation, and then that's being pressed through these insulating pieces, all juicy, onto a couple of heat sinks, and then it was directly screwed onto these heat sinks, which are the DC output part, the rectifiers and some regulators. Now there's a very dense thing, but I've been through, well, I've taken apart several of these in the past because I've got stacks of them, and I've already completely traced out the circuit for the primary side because I was planning to use that power supply for something and then changed my mind and didn't. So I've already taken apart one completely, removed all of the components, and then traced out the circuit that goes in there, including desoldering all the surface mount components which don't have like markings on them, and then measured them all to work out what they are. And then from that, and studying the board for a length of time, I've traced out the whole circuit of it, all the way up to the transformer. So that's the rectifier, power factor booster, and then transformer driver through that. Is it through a pulse transformer, drives the FETs, the main switching. That's all the gate drive business, and feedback, and then the auxiliary power supply, the top switch, feedback, and then this part here, the control board. You see the orange numbers there refer to bits that go onto the control board, which is this here, and connecting on there, and down here, and up there. So that's the main controller there, ML350 CP1. So that's a combined PFC boost converter and what is it, like half bridge driver PWM controller for transformers. And I worked out some things, 75 kilohertz roughly, main switching frequency. So that's the super micro power supply, and yeah, it's a useful source of a 450 volt DC at several hundred watts with a universal input, which is quite nice. And yeah, they have on some of the others soldered wires on to extract that DC to use for other experiments and things. Now we got the power supply from that big chunky server, that ML350, whatever it was. Now this thing, there's the ratings of that. It looks like it's made of 2 power supplies. So that folds out. Fan there. You see the AC input coming in here. These wires went on to 2 points there. So this appears to be a self-contained power supply with quite a lot of control and other things. And it appears to be one output, maybe one and something small. But then on the bottom, the AC wires also go down to that, and that looks like it's got probably 2 more power supplies on it. Presumably that there will be PFC boosting. So there's probably 2 more rails on there. So that probably has individual power supplies for the 5 volts, 3.3 volts, and the 12 volts. I guess that's what it looks like. It's pretty interesting. Perhaps we'll get these out a bit further and study them. Right, I got it out of the box. Wasn't that easy. Very nice having this on the carpet, isn't it? And so it's got a chip there. Fairchild ML350CP. That's a combined PWM controller and power factor boost converter controller chip. So that there is definitely the power factor boost inductor. And you can see there's a couple of turns with a different color wire, so that will be the auxiliary winding for the feedback. And then there's exactly the same thing over on this side. See, same chip there, same inductor. So this here will be 1 power supply rail, and the PWM controller in that Fairchild chip will be driving this main transformer here to provide a power supply rail coming on these orange wires. And then additionally there's probably the standby power supply there, and I'm pretty sure that's got, looking at the number of pins there are there, behind that transformer is a TO220 device, which is probably another one of those top switch, like 5 or 7 pin TO220 packages to drive that standby power supply. And then over on this side, 2 more main power supply rails. One of them will be driven by the PWM controller in that Fairchild chip, and then the other one will be driven by this chip here, UC3845, which is a little PWM controller. So there's 3 independent high current power supplies there, and you can see a bunch of feedback optocouplers there. Similarly there's 3, and then here there's several comparators and op amps, so that will be involved in deciding whether the power is good or not. And look at that, there's a whole bunch of little bits and pieces under there. It's probably some kind of monitoring thing. Not sure exactly what that says. Anyway, that's a very interesting design. I've not seen them use individual power supplies for each rail before in a computer power supply. Not like this, where it's got a main winding that's regulated, another winding, and then the 5 volts, there's a mag amp thingy that creates the 3.3 volts from the 5 volt rail. Alright, now I'm going to try and get this one out of the box. The last one here, still struggling to get that out of the box. There's some bars over here which are blocking a screw down there. I need to work out how to get that out. It might just be this insulator thing which has been glued, which is preventing it. I'll try and get that out, and then we'll explore that final power supply. Okay, finally got it out. Getting paste all over my hands. I think what the problem was, the end of all this, is that stud there, standoff, it's got a lip on it, so it pokes through the board a certain way. So the only way to get the board off of that is by lifting it, and didn't want to lift because this part here was screwed on the top of this, and that was pressing against this, and also the board is retained by that holder thing there. So it wasn't easy, but it's out now. And this one looks, well, we know, don't we, this one is it's a more, well, it's a single rail power supply other than the -12 and the standby, so it's just one main rail, 12 volts, so the one transformer to do that, and that will be the auxiliary, the standby power supply. And then again there'll be a boost converter happening with this here. Possibly those little wires coming off it are the auxiliary winding. So input filtering with inductors, common mode chokes, capacitors, NTC inrush limiting. Looks like there's a relay down there which probably bypasses the pre-charging stuff. And some pulse transformer down there, probably for driving some FETs. There's a little add-on thingy here. And then the main control board is on the side, the service mount board. See, that's the main side and that's the output side. So there'll be various comparators and things there for monitoring the rail, though it's only got a couple. And then probably these things. Looks like UCC something or other. That's probably a PFC thing, and that's possibly the PWM controller. Maybe? They guess without looking up anything. Yes, and then because of the high current on the output, they've got some bars there to join that onto the main board, and it connects onto these standoffs which are screwed into large planes on the board through multiple layers, I expect. Possibly that thing there, would that be ML350? Okay, it's just an op amp. Thinking there might be a synchronous rectifier diode controller, maybe. There might be one of those things somewhere. Maybe that's what's on that little add-on thing there. Alright, that's a look inside 3 servers and their power supplies, and a lot of interesting stuff that we discovered in there. Perhaps next time we'll have power back and we can do things in a nicer way, but we'll have to wait and see.